All right, so here I'm going to try and do a little live code, just walking through the process of setting up a new Scala SBT project. I'm going to use the advent of code as my sort of base for just giving myself something to do. And this is all based on myself having to relearn it because you don't start a new Scala project every day. So I'm just going to dive in and try and retrace my steps. And hopefully that will be useful. So a couple of prerequisites or assumptions that I'm making. First off, you have SBT installed, you have an appropriate Java working environment, and you also have IntelliJ IDEA CE, which is the free version, and it also has a Scala plugin, which will be necessary. I use the IDEA command line launcher, which you can add under the tools menu. There's an option to create command line launcher, and it really just gives you the ability to type IDEA. Okay, so I'm just going to start with problem one. And there's a little backstory here, but the ultimate goal is to take a text list that is numbers on a line, parse that, and find the two specific numbers that together will sum to 2020, and then multiply them to get the correct answer. And when you solve the puzzle, you can type it in there for credit. I'm not so concerned about that. I just want to create a new SBT project. SBT is a Scala build tool similar to maybe Bundler plus Rake, or the Yarn or NPM tools would probably be even closer, but it both manages your dependencies as well as allows you to define tasks. And I'll just be focusing on using it as sort of my dependency manager for today. So I want to create a new project. I actually had to look that up. And what we're going to do is a SBT new, and we're going to use a seed to give us sort of a starter for it. So the one I want, because I want tests, is going to be called Scala test example. And it's actually listed right down here. So I hit enter. It's going to prompt me for a name. And I'll call it advent of code AOC 2020. Okay, great. And now we can see I've got an AOC 2020 here. And I'll enter that. And I've got my very basic project with my build.sbt file, which is my core description of the SBT Scala build tool project. So from here, intuitively, because I have the command line launcher, I would type IDEA and open the directory. And so here it comes. But there's a problem in doing it this way. And in fact, it will get you, in many cases, oh, maybe it's not happening this time. IntelliJ can be very mysterious. So it looks like my SBT project was detected. And I can know that for sure if I open my build.sbt file. And if these names like settings and in this build, which have never been imported in my SBT file, are recognized, then I'm good. If it doesn't work out that way, what you're going to need to do is quit SBT completely. You're going to need to remove your .idea configuration folder. And then you are going to open it by saying idea build.sbt, and that will guarantee that it is interpreted correctly as an SBT project and not just a directory of files. So That's kind of a minor but very annoying gotcha to working with a Scala project. And if you're opening a project maybe at work and you can't get it set up, this is honestly the probably most frequent new user issue, at least for me, because I feel like a new user every time I have to reclone the project and open it. So just remove that idea file or idea configuration folder, and you can see it right here. If you remove that, then you can reopen it, opening specifically your build SBT file. Okay, so let's take a look at the project. External libraries we don't care about. We have a traditional Scala project here. It's all very similar to, in fact, it is basically a superset of Java, and you can write and import Java code and packages. And since this is a Scala test example project, it starts with a cube calculator object and a cube calculator test. These are pretty straightforward, but object cube calculator extends app means that if you ran this as a program, this is what you would get an app that has a cube method. If instead it was object cube calculator like that, and this were apply, this would give us a singleton object that can be called like that, I guess, with an int. We don't care about that today, though. In fact, we don't care about cube calculator at all. So I'm going to start out with a new package. So in my source main Scala, new package. I'm going to call it Advent. And then within that, I'm going to make a package, or sorry, just I'll start with Scala class, but I'm going to, yeah, we'll keep it as a class for now, stay simple. And I'm going to call it day one. And on second thought, actually objects are even easier than classes. This is not going to be something that has state. So again, object you can think of as a static class or whatever you want. You can see because I created it in the Advent package, it says package Advent. And by convention, your packages should match your folder structure, but that's not actually necessary. The package statement at the top is what matters. And within here, I'm just going to make let's do an apply method. Not. And this is going to take no arguments for now. F at the beginning. Say it's going to return an int, and it equals. Okay, well, I'm getting an error that I'm returning a unit, and unit is just sort of your null type in Scala, but we don't use null. So I don't have an implementation yet. Scala gives us a tool for this. It's 3 question marks, and I don't even know what, oh, it's called not implemented, and we'll see that more in a minute. Next, I'm going to create a test file, and I'm going to mirror my package structure here. So within the test Scala folder, I'm going to Advent, and then I'm going to actually copy paste this, make a new Scala test, and I'm going to call it day 01 test. Okay, it looks good. And I'm just gonna replace this part. So, this is not a useful test for me. So, say here, assert. What can I assert so far? I'm going to say day 01. And what can I do with that? Well, I have an apply method, so I can do that. And I don't know what it is going to do or what it's going to return yet, but I can probably say inside is instance of, and I want it to return an int. Okay. So now we've got this. I'm going to actually go down into my SBT shell, ignore my Scala format message. And so SBT, I could actually launch from the command line here now that I have a build.sbt file, or I could do it in the terminal using SBT shell. And I'm just going to run the test task. And okay, we have an issue. Well, first off, that's no good. Second, I'm just going to remove this. Now it's getting in my way. Try again. Okay, my test failed. What could it be? Oh, an implementation is missing. I feel like I should have seen that coming. Okay, but we have a test, so now we can start working off that. Thinking back to our requirements, we've got a list of numbers, and we're going to have to parse them first, right? So I'm going to get my puzzle input. And let's do this. Oh my gosh. Okay. Well, lucky for me, I've already got the puzzle input and I don't really want to spend time messing with downloads. So I'll just copy it. Jump back to IntelliJ here. And over here, I've got a source main. Let's make a new directory here and we'll call it resources. You can see because I'm not in the Scala directory, it didn't give me an option to make a package. And I'm just going to drag this over. I'm sorry for cheating on the part where you download something. So source means resources day1.txt, and I'm going to move it in. IntelliJ thinks that I'm trying to move it from another, but well, I'll deal with that later. Okay, here's my big list of numbers. Great. Get rid of cube calculator. In fact, let's make it go away completely. Okay, now I'm here. First, we're going to need some numbers. So val numbers. And what is that going to be? Well, intuitively, I would like to work with something that's not a text file. So let's think maybe we'll make it a sequence, which is our sort of base type for lists. And there are different sequence types, but basically we're thinking less about arrays and more about lists or linked lists, vectors, and different sorts of data types that are more optimized for functional programming. And now what? Well, I can do this again. And I could just return numbers.head or something like that to get the first element in the list, but that's not going to be correct. So next up, I'm going to turn to my friend, and soon all of our friends, Mr. Alvin Alexander. And specifically, Alvin Alexander has a post somewhere that, let's say, need text file. And so if you do anything in Scala, you're eventually going to be reading books or at least blog posts by Alvin Alexander. And he gives some different ways how to do it here. So I wanted to point that out. But again, I already have the implementation for this. So I'm going to start out by just copying it in. We could do this in our own separate reader class. And in fact, as the advent of code continues, that would probably be a good idea. But for simplicity's sake, I'm making a read file here. And what does this do? Well, first off, we're going to call IO, which is part of the Scala standard library, so I don't need to import it. source from file. I'm going to pass a file name in, and then I'm going to get the lines from it. And at that point, I haven't given any types here. Scala doesn't force me to, but if I try to use this, maybe I'll say, what was it, day1.txt. Oh, this is a sequence of strings. Get lines is returning a sequence of strings, not ints. That's no good. If I actually go to the lightning bolt here, I might be able to. Well, there's a way to add the type annotations automatically. There's other keyboard shortcuts that can do similar things. But for my purposes, I'm already getting feedback. So I'll skip figuring out how to find that. I have a sequence here, which I'm returning. And, oh, wait, here's my sequence of strings. So that's not good enough. So I'm going to start with that, but maybe what I really want to do is take my sequence of strings and map it. Scala has a nice shorthand for functions. I could write, string arrow string dot to int, and assuming in this case, I'm positive that they're all going to work. So I don't need to do any sort of optional parsing or conversion. I can just say, no, they're all going to work. But there may be a version like toInt option, which would return a wrapped type. I don't care about that today. An even more terse way of writing it is with the underscore. So this is the same thing. X arrow x to int would be underscore dot to int. Now I have a sequence of ints. Okay, so we've read our file. We've got our list of numbers. We've touched Scala tests. We've touched some different package and object types. And we just want to solve the problem now, please. Okay, so let's look at that. At this point, intuitively, if you've solved a problem like this before, I think you're going to want to iterate over the list. You're going to want to start comparing one number with every single other number in the list and find the combination of exactly two numbers that add up to 2020. And then for those, we're going to multiply them, and that will be the result. Sounds easy enough, but there's multiple different ways you can do it in Scala. And some are more verbose. We can use flat maps and maps for this. I'm going to use one that I think is kind of cool, but takes a little bit to wrap your head around. So first off, because we're going to be comparing numbers in the list, there might be a better way to do this, but I'm going to do something. I'm just going to do my solution first. We need indexes for our numbers. And so we can do that by saying, how about that? Numbers equals numbers.zip with index. And fix the typo. I'm just going to keep leaving that down there so it doesn't yell at me. And okay, now we have index numbers. It's a seq, and you can see the sequence with a type of parentheses int. So it's a sequence of tuples where the first one is the number and the second one is the index. Okay, well, keep that in mind. And again, by convention, we don't need to put type annotations on these because the compiler can tell what they are. But to be polite to people we're working with, they generally say that public members of whatever you're working with, like apply in this instance, should have a type. So I've got a sequence of pairs now, and I want to find the pair that fits. I know there's only going to be one because that's part of the problem. So I'm going to say val result equals, let's go to a new line, and we're going to use a for comprehension in Scala, which looks kind of like a for loop, but it's actually just syntactic sugar for a series of filter, flat map, and map functions. And I'll show you what I mean in a second. So I'm going to destructure my tuples. So let's say num1, comma, I1. So it's our first number and our first index of the two numbers that we're comparing. That arrow, and we say index numbers. Okay, and if I hover now, I should see, besides my declaration is never used, I pulled them out, so I have two, I have a first number and a first I. Great. That's going to turn into a flat map. And num2, I2, and I'm going to again extract that from index numbers if, and now here's where our filter function is going to get magically applied. I'm going to say num1 plus num2 double equals 2020. But if we have two, if the number 1010 is in there, we don't want that to count because we can only count each number once. We want two different numbers from the list. So I'll also add that the first index does not equal the second index. So if 1010 appears in there twice, that's fine. Now I have a num1 and a num2. And what am I going to do with it? I'm going to yield num1 times num2. So again, what this is doing under the hood or through syntactic sugar is saying, first, flat map index numbers and extract the number itself and its index. Then we're going to map over them. So now we've already, basically through closure, we have our first number. Now we're mapping over a second one. We can't keep flat mapping. The last one will be a map. And now we have num1 to compare to. And then finally yield. So what we end up with is for all that iteration, we're only going to yield in this if this final case has been passed, which means that if I hover on result is still a sequence of ints, and that's only a condition of the mapping and flat mapping. But what good is that for us? Well, we know because of the context of the problem that we don't need to that we don't need to worry about the length of our result. So I'm just going to return result, and then because the sequence is accessible like a function, I can say 0. And now if I run my test, I should be able to see it passed. That's great, but what's the actual answer to my problem? I can open a console from within SBT. And from here, I can say, do I have advent? Okay, so how about advent dot day 1? Oh, there's the advent day 1. Because it's an object, its type is day1.type, which I will never remember why that is, but it has to do with the fact that you can have a class called day1 and an object called day1, and they exist in separate namespaces, essentially. So they can, they basically combine together. And in your Scala code, where you would normally write static or class methods, you will instead write them on an object with the exact same name as your class. So for example, apply on the day1 object would probably be used to instantiate the day1 class without having to use the day1 class's new keyword. That's the most common use of probably apply on an object. So I want to say advent day1 that, oh, I have an answer. Okay. And since I haven't actually entered this into my advent of code yet, I am logged in. That's not the answer. Okay. And so it's 1010 299. I'm just going to type it. Oh, good. Oh, that would have been a huge waste of effort if I did this whole screencast and then it didn't work. So that, my friend, is how you solve a problem in Scala and also set up the whole project in between. I have one other solution here that I want to try and copy paste in, and maybe we can look it over real quick. This is from good friend Barry, and I'm just going to comment this all out. So I have no solution again. Paste this in. Now it looks like it's actually, we're looking for, well, let's figure out how this works. So we have an is 2020, and it looks like we're using a find function on that. We have a data reader, which I'm fairly certain is the class Barry used that should otherwise just work. Okay, so we've got find items. We've got product, and product calls find items with an n, which is our int. Scala tends to use very short variable names. And it tries to find is 2020. I don't know what combinations does, so I'm going to say here, I want to say that it finds combinations of 2, so that n would be the 2, but can I click into it? Oh, that's great. Iterates over combinations. A combination of length n is a subsequence of the original sequence with elements taken in order. So this is essentially doing my for loop or flat map and finding all of the combinations of elements that are within the collection. That's really cool. Okay, so I'm going to try this one more time. Day one, only now. My public interface is product. Product, and I'm going to pass in, I think, the number 2. I probably need to restart. So first, let's get this formatted nice. Exit console. So need to recompile. There's a way around that, but that's for another day of reading SBT docs. And can I do this now? Type in expressions, blah, blah. Oh, yes. Do I need to restart again? What a shame. Let's try that. It's day one text, right? Yeah. And there we go, 10.10.299. So yeah, Scala has extremely powerful collections API because it's all about functional programming, and pretty much every answer to a question of how can you do that, how can you handle an error, how can you do things without side effects, et cetera, how can you turn everything into a function, oftentimes comes back to, well, instead of having an error, have some kind of algebraic type that can be inferred as either good or bad, or either present or not. So because of that, there's far more methods around combinations and sometimes funky symbols that help you do combinations. You can see like here's our underscore shorthand again. In this case, because there's two underscores, we're saying argument 1 and argument 2. But Scala people just love this stuff. All right, Eric here, I'm back. I realized that I forgot to explain the second half of Barry's solutions. I thought it was worth going over that real quick. So where did we leave off? We had our combinations. We iterated over them, and we were in our find items. We have each combination. So essentially now we have a list of tuples similar to above. And now we're doing a find on that. So I was doing a filter for is 2020 and then controlling for duplicate indexes. Barry already has all of our unique combinations and is doing a find on it, which takes a function, or in this case, Scala knows enough to know that if it gets a method, it can convert it into a function. That's like another bit of syntactic sugar that comes for free. And it is saying here, int sequence, reduce left. So because we passed in the number 2, the reduce function is only working with 2. So reduce left, number 1 plus number 2 equals 2020. Difference here is that find takes that test function and returns an option. And specifically, I believe it returns the first element in the collection that satisfies the array. If so, you get one of the two types of options. You get the sum type with your matching result, so your matching combination. If you don't get that type, it returns a none. And similar to how the for loop up above wasn't really a for loop, but syntactic sugar for a map, flat map, and filter, our pattern matching in Scala looks a lot like case statements that you would see in many other languages, but they're much more powerful. And specifically what they can do, or probably most commonly, is they can destructure your data types. In particular, a type of class called a case class, which includes a lot of syntactic sugar, including the destructuring logic. So all this is saying is the result of this whole thing is going to be either sum, because it's an option, of these, and that sum is containing the single combination, the first one that matched the is 2020 function. If so, it is right here. We destructure it and return it because this is the last statement in our find items function. If it is a none, then we return sequence.empty. And this would be like our base case in many recursive case uses. So back up here, when we call find items, we are expecting a sequence to come out. And that sequence, we're going to apply one more reduce left to multiply it. It's possible that this sequence returns an empty. And in that case, we are going to do a reduce left, but we're not going to have anything to work with. So this is another case of how by using collections, the option type is a collection, but it's a collection of only one. The sequence type is obviously a collection. It can be a linear sequence. It can be indexed in other ways, but it's essentially, if we're using a plain sequence here, it's a linked list. So if we get an empty list, then...
So, slight correction here, you cannot apply reduce to an empty collection. It will error.
That pretty much covers the last of it. But in code that I work with, we use a lot of these match statements. They're generally called pattern matching. And I think it's actually a proposal for JavaScript as well. So something to keep your eye out for, even if you're not planning to learn Scala. And that's it. For real this time, I'm going on vacation. Have a great future.